Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a right regular pentagonal prism having edge of the base 25 mm and axis height is given to us as 60 mm. Now this pentagonal prism rests on its base on the horizontal plane with one of its base edges perpendicular to the vertical plane. So let us first of all evaluate the orientation of this pentagonal prism with respect to the horizontal plane and the vertical plane. Now if we orient the location of the pentagonal prism onto the horizontal plane in this orientation, so we observe that none of the edges of the pentagonal prism will be perpendicular to the vertical plane. So this orientation of the pentagonal prism on the horizontal plane is inappropriate or incorrect. When we locate the pentagonal prism onto the horizontal plane in this orientation, then we find that one of the edges of this pentagonal prism, it is perpendicular to the vertical plane over here. So this way, this is the correct orientation of the pentagonal prism with respect to the two reference planes over there. Now here we have the pentagonal prism. Now we know that a section plane perpendicular to the vertical plane and inclined to horizontal plane at an angle of 60 degree, it cuts the prism meeting the axis at a point 15 millimeter below the top face of the prism over here. So here from the top face 15 millimeter alongside the axis, a cutting plane will be passing through this particular pentagonal prism in such a way that this auxiliary inclined plane is inclined at an angle of 60 degree with respect to the horizontal plane. So with this information, we are required to evaluate the sectional top view projections, front view projections and the true shape of the cut section over here. Now let us first of all draw the top view projections of this pentagonal prism when the prism is resting onto its base on the horizontal plane with one of the edges perpendicular to the vertical plane. So we have been provided with this information that one of the edges of this pentagonal prism, it happens to be perpendicular to the vertical plane. So the top view projections of the pentagonal prism will be a pentagon shaped projections in which one of the edges we have taken as 25 millimeter and one of the edges it is perpendicular to the vertical plane. So we know that edge length corresponding to this pentagonal prism happens to be 25 millimeter. We have drawn the pentagonal projections onto the horizontal plane below the XY reference line having edge length is equal to 25 millimeter. So the 5 points corresponding to the top face of the pentagonal prism, they are 1, 2, 3, 4 and 5, while the 5 points corresponding to the base of this pentagonal prism, they are A, B, C, D and E. So we have plotted 5 points of the base on the inner side of this pentagonal projection, while the 5 points corresponding to the top face of this pentagonal prism have been marked outside these pentagonal projections which have been obtained onto the horizontal plane. Now in order to obtain the axis point, now we need to draw the perpendicular projectors from at least 3 of the corners of this pentagonal projection onto the opposite edge of the base over here. So from point D, we have drawn a perpendicular projector onto the base edge AB. Similarly, from the corner B of the base, we have drawn a perpendicular projector onto the edge DE of the base, and from the corner C of the base, we have drawn a perpendicular projector onto the opposite edge AE of the base. So wherever these 3 projectors from 3 of the corners of the base of the prism they have been found to be intersecting with each other, we obtain the axis points O and O1 over here. So the axis point O will lie corresponding to the top face of the axis, whereas axis point O1 will be lying onto the base of the axis over here. Now, having obtained the top view projections corresponding to this pentagonal prism, now let us obtain the front view orthographic projections of this prism. Now here, points A and B, they will be projected onto the XY reference line as points A dash and B dash. Points C and E, they will be projected as points C dash and E dash onto the XY reference line, and point D will be projected onto the XY reference line as point D dash over here. So these 5 points in the front view projections have been obtained onto the XY reference line, since these 5 points correspond to the base of this pentagonal prism. Now we know that height of the prism happens to be 60 millimeter. So once we mark axis height or the height of the prism as 60 millimeter, now we will be obtaining the projections of the 5 points corresponding to the top face of this pentagonal prism. So points 2 and 1, they have been projected as 2 dash and 1 dash over here onto the top face. Then points 3 and 5, they have been projected as 3 dash and 5 dash on the top face of the pentagonal prism, and point 4 has been projected over here as point 4 dash onto the top face of the pentagonal prism. Now axis point O dash onto the top face and axis point O1 dash onto the base of this pentagonal prism we have also been able to locate over here. So this way we have been able to obtain the front view projections as well as the top view orthographic projections of the pentagonal prism, which is resting on one of its pentagonal faces onto the ground with one of the edges of the base perpendicular to the vertical plane. Now we know that an auxiliary inclined plane inclined at an angle of 60 degree to the horizontal plane, it cuts the prism meeting the axis at a distance of 15 millimeter from the top face of this pentagonal prism. So we have marked a distance of 15 millimeter from the top face of this pentagonal prism. Now onto the axis, this is the point from where the cutting plane is going to pass through this particular pentagonal prism over here. Now we draw an auxiliary inclined plane inclined at an angle of 60 degree with respect to the horizontal plane, passing through this point on the axis, which happens to lie 15 millimeters below the top face of this pentagonal prism. Now we find that this pentagonal prism at 6 points over here. So we can check the vertical edges 1 dash, A dash and 2 dash, B dash have been cut by this cutting plane at points 1 1 dash and 2 1 dash over here. Similarly, the vertical edges of this prism 5 dash, E dash and 3 dash, C dash over here, they have been cut by this cutting plane at 2 points, that is 5 1 dash and 3 1 dash over here. And finally, the top face edges 3 dash, 4 dash and 4 dash, 5 dash, we can check 3 4 and 4 5. Now the cutting plane intersects both of these top face edges over here. So into the front view projections, these edges they become 3 dash, 4 dash and 4 dash, 5 dash. So the edge 3 dash, 4 dash has been cut by this cutting plane at the point 4 1 1 dash. The edge 4 dash, 5 dash of the top face of this pentagonal prism has been cut by this cutting plane at the point 4 1 2 dash over here. So these are 6 points of intersection which we have obtained corresponding to this auxiliary inclined plane cutting this pentagonal prism over here. Now let us obtain these points of intersection in the top view projections over here. So now we know that point 1 1 dash It is the point of intersection of the cutting plane with the vertical edge 1 dash A dash over here. So if we bring a perpendicular projector from the point 1 1 dash into the top view projections, now it is going to intersect vertical edge 1A at this point. So this will give us the point of intersection of the cutting plane with the vertical edge. So we can check points 1A and 1 1. So all of these 3 points, they have coincided with each other, right? Because they are lying perpendicular to the horizontal plane. Similarly, 2 1 dash is the point of intersection of the cutting plane with the vertical edge 2 dash and B dash over here. So again, if we draw a vertical perpendicular projector from 2 1 dash into the top view projections, then we find that this will be the point of intersection of this vertical projector drawn through the point 2 1 dash with vertical edge 2B over here. So this way, the points 2B and 2 1, they are all going to coincide with each other in the top view projections, because all of these 3 points, they are lying onto the vertical projector line, which is perpendicular to the horizontal plane over here. Similarly, we are going to get 2 points of intersection over here. That is 3 1 dash. It is the point of intersection of the cutting plane with the vertical edge 3 dash C dash over here. So if we draw a vertical projector line through 3 1 dash, it is going to intersect the vertical edge C3 over here at this point. So this point will be 3 1 in the top view projection. So the points C3 and 3 1, they are going to coincide with each other over here. Next we have got point 5 1 dash. So point 5 1 dash, again it lies onto the vertical projector line 5 dash E dash, as it is being intersected by the cutting plane over here at this point. So from 5 1 dash, if we draw a vertical projector line, it will be intersecting with the vertical projector E5 over here. So the points E5 and 5 1, they are all going to coincide with each other, because these 3 points, they lie alongside the vertical projector line 5 dash E dash, which happens to be perpendicular to the horizontal plane. Now next we have got 2 points over here, 4 1 1 dash and 4 1 2 dash. So 4 1 1 dash point lies on the top face edge 3 dash 4 dash over here, while point 4 1 1 dash, it lies alongside the top face edge 4 dash 5 dash over here. So once we draw vertical projector through the points 4 1 1 dash and 4 1 2 dash, wherever this vertical projector line intersects with the top face edge 3 4, we obtain the point 4 1 1. Wherever this vertical projector will intersect with the top face edge 4 5, we obtain the point 4 1 2 over here. So this way, all the 6 points of intersection of the cutting plane with this pentagonal prism have been obtained in the front view, and all these 6 points of intersection, they have been obtained in the top view projections over here. Now let us join the remaining portion of the solid using object line. So we can see this is the remaining portion of the solid which is left behind, and this portion of the solid has to be removed over here. Similarly, in the top view, we find that this portion of the solid, it has been cut by the cutting plane. So this portion of the solid has been cut by the cutting plane, and we have been able to obtain the apparent shape projections corresponding to the cut section into the top view projections over here, and this sectional top view is going to represent the apparent shape of this particular cut solid over here. Now another thing we need to evaluate over here, that this portion of the solid will also be visible to the observer from the top view projection. So this way, here this is the sectional top view of this apparent shape of the cut section, which is visible to the observer looking at this particular cut section from the top view. But this portion is the uncut section of the solid. So we need to join the points 4 and 412. We also need to join the points 411 and 4. So this portion, it is the uncut portion of the solid, which will also be visible to the observer in the form of a true shape projection in the top view projections over here. Now we are also required to evaluate true shape of this cut section. So we know that there are 6 points of intersection which are available alongside this cutting AIP over here. So in order to obtain the true shape of this cut section, we need to draw an auxiliary inclined plane x1, y1, which should be parallel to this cutting plane, or it should be parallel to this cut section over here. Now, from all of these 6 points, we need to draw the perpendicular projectors onto this auxiliary inclined plane, and now the projections obtained onto the auxiliary inclined plane, that is the auxiliary plan projections. So they will provide us with the true shape of this cut section over here. So let us evaluate the auxiliary plan projections obtained onto this auxiliary inclined plane. So here we have got the locus line emerging from the points 1 dash and 2 dash over here, which are the points of intersection of the cutting plane with vertical edges 1 dash A dash and 2 dash B dash respectively. Now we need to measure the distances of the points 1 1 and 2 1 from the XY reference line over here. So once we measure the distance of the point 1 1 from the XY reference line, now onto the projector line emerging from 1 1 dash, now we are going to mark the same distance of the point 1 1 over here. So once we mark this distance of point 1 1 from the XY reference line, mark this distance onto this projector line over here, point 1 1 will be located in the auxiliary plan view. Similarly, this is the distance of point 2 1 from the XY reference line. So once we evaluate this distance of point 2 1 from XY reference line, now onto the projector line emerging from the point 2 1 dash, we are going to mark the same distance onto this projector line over here. So this will provide us the location of the point 2 1 in the auxiliary top view projections over here. Now the next 2 points available with us, they are 3 1 dash and 5 1 dash. So similarly, we will be measuring the distances of the points 5 1 and 3 1 from the XY reference line. So once we measure the distance of point 3 1 from the XY reference line, now onto the projector line emerging from the POI point of intersection 3 dash, now ahead of the plane, same distance of the point 3 1 will be marked over here. So this way, this distance of point 3 1 and this distance of point 3 1, they will be the same. So this point 3 1 has been obtained in the plan projection view. Similarly, if we evaluate the distance of this point 5 1 from the XY reference line, now onto this projector line emerging from the point 5 1 dash, now if we mark the same distance of point 5 1 over here, so point 5 1 will be located onto the plan projection view. And last 2 points, they happen to be 4 1 1 dash and 4 1 2 dash point over here. So 4 1 1 dash, it lies on the top face edge 3 4. 4 1 2 point of intersection, it lies onto the top face edge 4 5. So now when we measure the distance of the point 4 1 1 from the XY reference line, now onto this projector line emerging from 4 1 1 dash, if we mark the same distance, point 4 1 1 will be located over here into the auxiliary plan view projection. And finally, here we have this point 4 1 2. Now we are going to measure the distance between point 4 1 2 from the XY reference line. Now onto the projector line emerging from 4 1 2 dash, if we mark the same distance over here, we obtain the point 4 1 2. So all the 6 points of intersection, they have been appropriately obtained into the auxiliary top view projection over here. So once we obtain this auxiliary plan view projection onto the auxiliary inclined plane which was drawn parallel to the cut section over here, so we have been able to obtain the true shape projections of this cut section whose edge view is visible to us onto the horizontal plane, whose apparent shape projections, they are visible to us into the top view projections over here. So this way we have been able to obtain the front view orthographic projections, the top view orthographic projections corresponding to this truncated pentagonal prism over here, and we have also evaluated the true shape projections corresponding to this cut section using an auxiliary inclined plane x1 y1 parallel to the auxiliary inclined cutting plane over here. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic front view and top view projections of the section solid and evaluation of the true shape of the cut section when the solid has been cut by an auxiliary inclined plane. So we are going to continue with further discussion regarding few more illustrative cases of sections of the solids in the coming lectures. Thank you very much. Thanks a lot.